Okay, so in this lesson, we're going to talk about graphing quadratic functions. And remember, this is a continuation of section 3.1. Now, before we talk about graphing quadratic functions, you need to go back and review. You need to review the worksheet part 1 on this section. So in that worksheet, remember, that's where you were given a quadratic function that's in vertex form, and you were asked to find the vertex, the axis symmetry, domain, range, and so on. And on the other two problems, that's where your quadratic function was in standard general form, and again you were asked to find the same information. Okay, so again, before you start graphing these, make sure you go back and review this worksheet. So part 1. All right, now assuming you've done your review, let's talk about how to graph the quadratic functions using this information. Plus the only other thing we're going to do now is this. So we're going to now talk about, well, how do you find the y-intercept and how do you find the x-intercept? Okay? All right, so that's what we're going to talk about. Okay, so in this lesson, we're going to look at graphing quadratic functions that's in vertex form. Vertex form. In the next one, we're going to look at standard form, but in this case, it will be vertex form. So remember, a quadratic function in vertex form has this form, a times x minus h squared plus k. All right, where hk is the vertex. Okay. Now, so let's look at the first one. So you want to graph each quadratic function, and if necessary, round the x-intercepts to the nearest tenth. So you can see what that's going to look like. So in this one, you have x plus 3 squared minus 16, and you want to find the vertex. So remember what you got to do. Don't make the mistake and say that the vertex is 3 negative 16, because it's not. So remember, it's got to look like this, x minus h. So you see where you have that x plus 3? That's the same thing as saying right here, x minus a negative 3 squared minus 16. So my h is negative 3 and my k is negative 16. So the vertex is negative 3, negative 16. So that's your vertex. All right, now before we graph this, you remember you can determine the domain and range. And I want you to remember this when we talked about this. We're graphing quadratic functions, and in quadratic functions, regardless of where the vertex is located, it's either going to open up, and remember it opens up if a is positive, or it's going to open down if a is negative. All right, so we talked about that in the previous lesson. And regardless of whether it opens up or down, remember the domain is negative infinity to infinity. That's the domain, negative infinity to infinity. So for every quadratic function, the domain is all real numbers. So every real number is possible for x. Will be an x value in the domain. So as an inequality, will be negative infinity to infinity. And if we get to that point this semester, hopefully we will, but if we get to that point, you're going to also learn that every polynomial function, and a quadratic function is a polynomial function, every polynomial function, all right, every polynomial function, the domain will be all real numbers. All right, so right away, I can do this. I can, in both cases, if I want to, in this example and in this example, I can say the domain is negative infinity to infinity. Negative infinity to infinity, all real numbers. All right, now the range is not the case, because remember the range there's a in this case a minimum value, and in this case there's a maximum value. And so your your range depends on whether you have a minimum value or a maximum value. Okay? So it depends on whether it opens up or opens down. So let's kind of talk about the range for number 1. So again, you don't have to graph it just yet to determine this. So number 1, we know that the vertex is -3, -16, and that is in quadrant 3, -3, -16. And I also know that the parabola opens up here because the coefficient, because a in this case is a positive 1. So it's positive. So the parabola is going to open up since a is positive. All right, now remember this point right here, the vertex is -3, -16, and we're trying to find the range. That's what we're trying to find. So remember, when finding the range, you go from bottom up along the y-axis. So then I touch the graph at this low point, at this minimum. And so remember, you're trying to find the range, a set of y-coordinates. So your question is, what is this y-coordinate right here? Well, this y-coordinate, remember, is -16. That's that y-coordinate. So you're going from -16 all the way, and there's no maximum because of these arrows, it keeps on going, all the way to infinity. So your range is bracket -16 to infinity. All right, and we could do the same thing in this case, but we'll come to that in a little while. All right, so that's your range. So from -16 to infinity. Now let's talk about how to find the y-intercept. All right, now listen carefully. So remember when you graph lines using intercepts, remember to find the y-intercept, you're going to let x equal 0. That's what you did. You let x equal 0. Because remember the y-intercept is where the graph crosses the y-axis. And no matter, if you think about it, just as before, if you look at the y-axis, no matter where the graph crosses the y-axis, whatever the graph may be, wherever it crosses the y-axis, the x-coordinate is always 0 in every instant. And so if you want to find where the y-intercept is, you let x be 0. All right, so you go back to your function and you find f of 0. That's what you do. You let x be 0, so you find f of 0. So I have 0, because that's x is 0, plus 3 squared minus 16. And so 0 plus 3 is 3, 3 squared is 9, and 9 minus 16 is a -7. So my y-intercept is a -7. Now, chances are they're going to ask you to write this as an ordered pair, so let's just write it as 0, -7. All right, so x is 0, y is -7. So that's my y-intercept. Now let's go by the x-intercepts. All right, so remember to find the x-intercept, so if you remember what we talked about in previous lessons, no matter what the graph looks like, if it crosses the x-axis, remember the y-coordinate is 0. The y-coordinate is 0. So if you want to find the x-intercept, you let y equals 0. So remember, in function notation, f of x means y. So that's y. Okay, so you're going to set this function equal to 0. That's what you're going to do. All right, now be careful how you do this. What we're doing. Set that equal to 0. All right. Now remember, this looks like you're going to be using the square root property. So remember, in one of the previous lessons and on the tests, on a quiz, on worksheets, you had this situation where you were to solve this quadratic equation where you had an expression squared. The best way to do this is to use a square root property. But remember, when using a square root property, you have to get that binomial squared by itself, and on the other side you had to have that number, a constant. All right, so the first thing you do is you're going to add 16 to both sides. And so I get x plus 3 squared equals 16. Now remember, at that point, that's where you took the square root of both sides, plus or minus. Don't forget the plus or minus. So you had x plus 3 equal plus or minus, and the square root of 16 is 4. And then you remember, you then wrote it as two separate equations, because that was going to be our rational solutions. So you said x plus 3 equal 4, x plus 3 equals a negative 4. And then if you subtract 3 from both sides, you found one of your x-intercepts. One of my x-intercepts is 4 minus 3, which is 1. And over here, the other x-intercept is negative 7. So as an ordered pair, though, you would say the x-intercepts are 1, 0, comma, and then negative 7, 0. Okay? All right, now let's talk about how to graph this now. Okay, so listen carefully. When graphing a quadratic function, you need to know the vertex. You have to know the vertex. All right, so the vertex is negative 3, negative 16. So again, negative 3, negative 16 is right here. So that's your vertex right here. All right, so that's negative 3, negative 16. Now, don't draw the parabola just yet, because you want it to look as nice as possible. So we're going to use all this information now. The y-intercept, you need to put the y-intercept on there. So the y-intercept is 0, negative 7. So the parabola is going to cross the y-axis here at 0, negative 7. You also know that, that there are some x-intercepts here. And the x-intercepts are 1 and negative 7. Okay, so remember this. What we're going to do now, 1 and negative 7. All right, so that's what we have. 1, negative 7. All right, now listen carefully. At this point, what I would then do is draw the axis of symmetry. The axis of symmetry. The axis of symmetry will help us to draw a somewhat nice looking parabola. All right, so the axis of symmetry. So make sure you draw that. Axis of symmetry. So in the previous lesson, you talked about the axis of symmetry. So remember, the axis of symmetry, and we're going to use the dotted line for that, goes through the vertex. All right, so in this case, so if my vertex is negative 3, negative 16, the axis of symmetry, remember it's a vertical line, so you're going to say x equal, the axis of symmetry is x equal negative 3. And basically all you're going to do is this then. So you're going to take your ruler, and I guess I should use a longer ruler, but you're going to draw a dotted line. I don't know if you can see that. I'm going to draw a dotted line, just like this, a vertical line, and I'm not drawing it very well. That goes through the vertex, just like this. Goes to the vertex. All right, just like that. Goes to the vertex. All right, so that's, let me go ahead and make it a little bit smaller. All right, so here's my axis of symmetry. All right, now listen carefully to this. So it's the axis of symmetry. So this axis of symmetry makes the parabola symmetrical. All right, so we talked about the idea of symmetry. And I want you to notice this. See where you have those two x-intercepts? The distance that this x-intercept is from the axis of symmetry, if you look at it, it's 1, 2, 3, 4. And this distance also 4. 1, 2, 3, 4. So the distances are the same. So if you know this point, and that's 4 units, then you know another point on the graph, that's also 4 units. All right, so if you look at this right here, see you have the y-intercept? Well, how many units is a y-intercept from the axis of symmetry? Well, it's 1, 2, 3. Well, remember, the parabola is symmetrical about the axis of symmetry. So if that's 3 units, then the other point on the other side is going to be 3 units from it. 1, 2, 3, and have another point. And I didn't even have to actually find it in terms of using the function. I just used the y-intercept. That was 3 units, so this has to be 3 units as well. And that's really all you need. And so you just do the best you can with drawing the parabola. Now this is going to be a little bit more difficult because of how spread out it is. But do the best you can. Use a pencil, erase, make it look symmetrical. Do the same thing on this side. All right. Do the same thing on this side. And before we go on, just keep in mind that this distance has to be the same as that distance has to be the same as that distance, and so on. Okay? So there's your problem. That is number 1. So that's the function f of x equal x plus, what was it? It was x plus 3 squared minus 16. All right, so that was number 1. Okay, now let's look at number 2. So number 2, we have this function, and let me go ahead and enlarge it here. All right, so we have this function, and remember at this point you should be able to tell what the vertex is because it's in vertex form. So the vertex is 2, positive 7. 2, positive 7. All right, let's talk about the range. All right, so remember the vertex is number 2. The vertex is 2, positive 7, so that is in quadrant 1, 2, positive 7. And we know that the parabola, since a is negative, that the parabola is going to open down. Okay, we know that. So we know the parabola is going to open down, just like this. And so therefore you know the range. So you see how your parabola is opening down, the arrows are going down, so you're going from negative infinity all the way. And then the largest, see the vertex here is a maximum point, so the largest y value, because that's range, is 7. So the range is from negative infinity to 7 with a bracket. All right, let's go about the y-intercept. We're going to do the y-intercept just like we did this one. You're going to let x equal 0. So to find the y-intercept, you're going to let x equal 0. And so wherever you see the variable x, you're going to substitute 0. So I get negative 3 times 0 minus 2 squared plus 7. Use your order of operations. 0 minus 2 is a negative 2. Negative 2 squared is negative 2 times negative 2, which is a positive 4. Positive 4 times negative 3 is a negative 12. And negative 12 plus 7 is a negative 5. So my y-intercept is 0, negative 5. Okay, so far I know this, and I'm going to go ahead and use this graph here. So far I know 2 things. I know the vertex, so you need the vertex, so that's going to be the highest point, and you know the y-intercept, so the graph's going to cross the y-axis at negative 5, so that's here. Now, at this point, I would go ahead and draw the axis of symmetry. Draw the axis of symmetry. Make sure you use dotted lines, though. Always use dotted lines for the axis of symmetry. And the axis of symmetry will help you to make a symmetrical looking graph. Now, I want you to remember this. If this is my y-intercept, which it is, and so if you know the y-intercept, then you know another point of the graph. So use it. You must use it. So if this, how many units is this from the axis of symmetry? Well, that's 2 units. 1, 2. Then the other point is going to be 2 units as well on the other side. So 1, 2. All right. So now you know 3 points on this parabola. You need at least 5. And so that's where the x-intercepts are going to come into play. All right. Now this is going to be a little bit more challenging though, and you're going to see why. So let's talk about the x-intercepts. To find the x-intercepts, you let y equal 0. And so remember, f of x is y, so that's 0 here. So that means that this expression is going to be equals to 0. So I get negative 3 times x minus 2 squared plus 7 equal 0. All right, now whenever it's in vertex form, and you're finding the x-intercepts, just like we did here, you want to use the square root property. Use the square root property. You had that on a previous test. All right, now, so to get the square root property, to be able to use the square root property, that means I've got to get x minus 2 squared by itself. All right, so let's get rid of this 7 first. So I get negative 3 times x minus 2 squared equals a negative 7. Negative 7. Then I'm going to divide both sides by negative 3. And be careful. So negative 3 divided by negative 3, that's 1. So you do get x minus 2 squared equals, now remember, a negative divided by negative is a positive, so that's 7/3. Okay? Now, this is the challenging part here, because over here, see that was a whole number, that 16. Here, you have a fraction. All right, so now don't write the decimal because 7/3 does not terminate, so leave it as a fraction. All right, the next step is to take the square root of both sides, plus or minus, and so you get x minus 2 equals plus or minus the square root of 7/3, just like that. Now, remember in a previous lesson you rationalized the denominator. Don't do that here because you're just approximating the x-intercept, so don't worry about that. Don't rationalize. Just leave it like this. Leave it like that. And so therefore x equal, adding 2 to both sides, you get x equals 2 plus or minus the square root of 7/3. All right, so let's approximate what these x-intercepts are. So the first x-intercept is going to be approximately equal to, and remember you want to round to the nearest tenth if possible, so that's where we're going to do this. All right, so take your calculator out, and so let's figure out what one of my x-intercepts approximately equal to. All right, so now here's how you're going to do this. So you're going to say 2, you're going to say 2 plus, and then the square root. Now notice you put parentheses, so you're going to say 7 divided by 3, close the parentheses, and then press equal. So one of my x-intercepts is approximately equal to 3.5. 3.5. All right, so that's the first one. The other one, you're going to say 2 minus the square root of 7 divided by 3, parentheses, equals. And the other one is nearest tenth, so it's about 0.5. 0.5. All right. Okay, now let's put that on the in terms of an ordered pair, you would say, now remember these are approximations, so just keep that in mind. These are approximations, so you would say 3.50, and the other one would be 0.50. These are approximations though. APPROXIMATIONS, approximations. Okay, so 3.5 is, let's see, 3.5 is about here, you see right here, and then 0.5 is about here. Okay, so those are my x-intercepts. And remember a while ago we talked about the fact that these distances have to be the same? So does it look like this distance is the same as that distance? Yeah, it does. Okay? And I want you to notice something. If I were to add these two together, 3.5 plus 0.5, so 3 and 5/10 and 5/10, so 3.5, if I add them together, 3.5, and obviously we all know that's 4, but let's just go ahead and do it on a calculator. And if I take half of that, I did 4, so let's do it again. 3.5 plus 0.5, you get 4. And if I take half of that, I get 2, right? Well, what is the axis of symmetry? Well, the axis of symmetry is x equal 2. And it kind of makes sense because remember we talked about midpoint? So if you look at these two endpoints right here, that was a segment. So if we add the x coordinates, 3.5 and 3.5 here and 0.5 here, 5/10, add them together and divide by 2, I get the axis of symmetry. Okay? All right. So we have enough points now, 1, 2, 3, 4, 5, to draw a kind of as best a parabola as we can draw. All right, so now make it look like a parabola though. Don't make it look like segments. So if you got to erase it, erase it. I'm using a pen, so I won't be able to do any erasing. So that's one part of my parabola. And then over here, I look at the other one. Again, erase if you have to. And here's the other one. Okay, so it kind of looks okay. I mean, it's not drawn very well, but it's the best I can do at this point. All right, so that is graphing. So what we did is we graphed two quadratic functions that were in vertex form. And notice that when we found the x-intercepts, this one was square 16 was a 16 is a perfect square, and so I ended up with some nice integers as my x-intercepts. Over here, though, that's where I had to approximate. All right, now the other thing I need for you to remember is this. Whenever you graph these, whenever you find the y-intercept, use the idea of symmetry to find another point. So if this is one point, that's 2 units, then go 2 units this way, you find another point. Whenever you graph the x-intercepts, these distances should be the same. And if you were to add them and divide by 2, you'll get the axis of symmetry. And you always must plot the vertex because the vertex is part of the graph. That tells you the high point or the low point. All right, now, one other thing I need to mention. So notice that in both those examples, you had x-intercepts, right? You're not always going to have x-intercepts. So I just want to mention that because we're going to look at one of those later on. But look, if the let's say the vertex is in quadrant 2, and let's say A is positive, so it goes up. Does the parabola cross the x-axis? No, it's not going to have any x-intercepts. The ones we did, though, in 1 and 2, they did. Because if you look at what we had, if I can get to it, see number 1, the vertex was in quadrant 3, and it opened up, so I did have x-intercepts. And number 2, the vertex was in quadrant 1, and it opened down, and I did have x-intercepts. But that's not always going to be. So there will be situations where the vertex will be in a quadrant 2, let's say, and it opens up, or it could have been in quadrant 1 and it opened up, or it could have been in quadrant 3. And what do you think is going to happen? What do you think would happen if there were no x-intercepts in this one? Well, it would open what? Down. If it's in quadrant 4 and it did not have any x-intercepts, and that means that it has to open down. So those are the situations where you would not have x-intercepts. But you still want to plot at least 5 points. At least 5 points. Okay, one of them being the vertex, and the other one being the y-intercept. Because you're always going to have a y-intercept, always. You say, well, this one doesn't. Yes, it does. Remember, it keeps on going like this, so we'll have a y-intercept. This will have a y-intercept. It's going to have it has to have a y-intercept because remember the domain is all real numbers. Domain's all real numbers, so it has to have a y-intercept. So these two you definitely will have. You may or may not have x-intercepts, but if you do, those would be your 5 points. The vertex is 1 point, the y-intercept is another, and then use symmetry to find the other point, so that's 3, and then the x-intercepts would be 2 more. If there are no x-intercepts, then just find 2 other points on that parabola and then use them. Okay, so that is the end of this lesson where we talked about graphing quadratic functions that were in vertex form. The next lesson, we're going to talk about graphing quadratic functions that are in standard form or general form. So in other words, it's not in vertex form. Okay, so that's the end of this one.